Okay, I'm gonna get started. I'm Louis. Today I'm going to be presenting on web hacking. So thank you guys for coming. I know it's a rainy day. Awesome. So for announcements, we have we're playing NBCTF at 6 p.m. tomorrow. I think the room's not sure. We're not sure where, but probably in the ACM office. And we're gonna have a CloudSec meeting this Sunday. So please come. And for next Tuesday, we're not planning on having a meeting. We're probably gonna have dinner at the meeting time. Look out for announcements on the Discord server. You guys can hear me all right, right? Okay, I'll just speak then. So today's meeting flag is they all start with S. It was the same as last year, but I think a lot of these attacks, obviously on the server, and I think in the past we had more attacks that started with S, but this year when you have one, so this is a guy kind of molding on a server, even though it's probably his fault that his code has vulnerabilities. Yeah, I think if you guys came to web hacking too, part of it was like more client-sided stuff and web hacking one as well. So right now, this third meeting, we're focusing more on the server-sided attacks. Awesome. We all good? Oh, wrong way. So for today, we're going to talk about 4 different types of attacks. Most of them are fairly short. We're going to talk about command injection, template injection, path traversal, and server-sided request forgery, which is shortened to SSRF. I'll give a short overview of the attack and what you need to know for it, and give an example of the attack on a short application. So the first one, command injection, I think it's fairly self-explanatory. Basically, you have applications that execute commands, so it's usually shell commands, and they might take user inputs that you can modify, and in that way, you can add your own commands within the input and escape from what the application developer originally intended. So for example, you might have a web application that might call external scripts. I've seen applications called cat. We have a challenge that calls a binary called cowsay. And the user input would just be passed into the argument of the script or the binary. But you have ways, if you don't escape things properly, you have ways to, kind of bypass what the application developer intended and escape from the shell argument. And you can execute more commands in that. So one fairly common way is you can use semicolons or double ampersand to run multiple commands at once, right? So let's say the original application developer only intended for you to run ls. Let's say they directly concatenate the string at the end. Then you can actually, do something like this where you add semicolons and run other commands that you want. So yeah. And one really quick example is what I mentioned just now, cowsay. So usually you'd have, let's say this is a Flask web server. So a user might want to tell, put an input for something like, give me some input. So that's the default string. So this binary, what this binary does is it renders like an ASCII cow, and it says something, says exactly what you put in. So you can say the input, give me some input. But if you see, we don't escape anything here. The double quotes are actually, within the string. So if you put in the double quotes and use what we had just now with a semicolon or a double ampersand, you can run extra commands at the very end. And the cowsay will run, but it'll also give you, the ability to run extra commands at the end and, do whatever you want. So let's say read a flag file or something like that. So this is really basic, but it's actually quite common in applications that people write because they don't think about different shell tricks that you can do. And moving on, the second one is template injection. What this involves is server-sided templates, which I'll explain later, and the ability to run kind of a limited subset of code within the template. And if the application developer doesn't also sanitize the input properly, you could run code inside a template that will run arbitrary code, which is not what you want as a developer. And it's called server-side template injection because this is when this is specifically for server-side templates. You could have client-side templates that might end up running code like XSS on a client's computer, but we're only going to focus on the server-sided one. So a really basic overview of templates. They're basically static files of HTML or something. It doesn't have to be HTML, but usually it is, where you have stuff like this. So you have variables that you can substitute in. And when a client requests the website, the web server, so this is I think in Python syntax, Flask syntax, it'll grab the HTML file, the template file, and substitute in variables. So in here, you can have title set as something else, and it will replace it and give it back to the client. And it's nice because, as a template would suggest, you could reuse it for different components of your application. And templating is not just for strings, right? They support actually a lot of operations. You have statements and expressions, so some give you outputs, some don't give you outputs. In Jinja, for example, this is how you write a statement and write a template, write an expression. And if you do like 4 divided by 2 inside the template, it'll give you the number 2. So it actually runs the code inside the the brackets. And if you give it like something like request in Flask, which is just a variable available to the template, it will give you the output. The output will be the object itself. So if you see later on, you can use this object to do malicious things. So we're going to focus on Jinja, which is fairly common with Python Flask. But this also applies to like other templating engines. For Flask, there are a few objects that are fairly common. Config, which is like the Flask configuration, which might have secret keys for environment, something you can steal. And there's also requests. Later on, I'll show you how you can use it. So if you have a template, and let's say you control a server-side template, you just put in this thing, config.items. It'll actually give you all the Flask config items inside the configuration. You can see secret keys. I think there's a slide later. I'll show you that. And if you do something like request the application on globals, this looks a bit weird, but this is actually pure Python, right? And this will give you access to global variables available within the context. And later on, you'll also see you can use this to run arbitrary commands if there is no filtering. So for example, this is a very simple runnable Flask application. If you concatenate a user value, so let's say the user gives you, the user sends the application a string guest. If you concatenate it at the end and you substitute it in the template, it'll give you stick around guest inside the template. But if the user actually passes in a template string with the double brackets, and you put in like 1+1 or requests or some other stuff, some other code that you might want to run, it will give you it will render 2 at the end, like I suggested at the start. So this is bad because you give the user control over the entire templating part. So usually you want to give users control over the inside, and everything will be rendered as a string. But if you give them control over the entire templating brackets, they can run any code they want. And if you run the previous item and run it locally, you can try putting in different things as a user parameter, and it'll give you different things like this. So this is what config gives you. And in Flask, it's like common to put a secret key as a Flask config variable. So if you run this in production and someone has access to template injection, you're kind of screwed. They can see your secret keys. And if if there's no filtering at all, you can actually run system commands by doing this. This is kind of like a Flask specific bypass, but I think I've seen it quite often in CTFs as well. So I want to keep note. And all of this is the functions available to you when you do globals. Obviously, you can't see it, but if you run it on your own, you see there's actually a lot of Python functions. Okay, so moving on, the third attack, we have path traversal. This one's also fairly simple, I think. If you guys used any Unix-based systems like Linux or on your Mac, you might know there's // which gives you the parent directory. And using that, you can you can put this dot dot slash in different ways and access files that the server might want to like prevent you from accessing, right? So let's say the server wants to serve you files from a certain folder, but you can go behind, like go to the parent folder and go to the parent folder and access files that probably shouldn't be able to access. So just some context, Unix paths, there are two types. There's absolute paths that start with a slash, so that's like the root of the drive, and there's relative paths where it doesn't start with a slash, it can just start with a folder name, or it can start with dot slash, which is like the current directory. And the parent directory is double dot. So for example, if you have a path like this, so home SIGPwny, double dot, secret files / flag, this actually goes back to directories, right? So home SIGPwny, and if you go back, you're going to end up at the root. So this is actually what ends up being kind of parsed. And this is not good, because if you want to only give users access to home / SIGPwny / everything else, you need to filter out these dots, or not they can actually go back and access your secret files that might not be within the folder. So this is a quick Python example of Flask again. Most of this is not relevant other than this line where we join the path. So this is a Python function that allows you to create path strings. And let's say you want to only allow access to my secure directory. So whatever file that you pass in, let's say default.txt or help.txt, we only want to let the user read from this directory. But if you read about the behavior of os.path.join, it lets you use double dots, so you can go to the parent. So if you do something like this, double dot / etc.password, this is a common Linux or Unix file that gives you kind of hashes of the user passwords. You can bypass this kind of intention to lock you into this directory. You can read back and actually read the /etc/ password file, which is not intended. And there's actually another way to exploit this. If you read about the behavior of this function, different languages and different standard libraries have different behaviors, but if any of the paths after this thing is also an absolute path, it'll actually override the previous provided string. So even without the double dots here, it will still work. But
that's surprising.
Yeah, so it's really behavior that you should read about when you read the documentation. So people are always surprised, but if you go into the Python documentations, it tells you if you have absolute paths afterwards, it will replace everything beforehand. So you have to make sure when you write your code, you know what's happening, or not, you'll run into something like this. So in this case, removing double dots is actually not enough. You need to make sure you don't start with the absolute path. Okay, finally, we have server-side request forgery, SSRF. So this is kind of using the server code or server requests to run your how do I phrase this? Accessing your private resources. So something that you can't access, but only the server can access. But using the server's identity to do that. And what I mean by that is, let's say you have a website, example.com, and obviously internally it has databases and APIs, right? But these databases and APIs aren't accessible to the outside world. Usually they're in like their own private subnet that's firewalled off of the entire real world. But if you have a way to let something in the internal area access the database, or access the API, or access something else and return the data back to you, you have a way of bypassing this internal thing, right? Because you're using someone's a resource inside the internal group and returning data to you, who is like outside in the external world. So as I mentioned, it returns data from internal services, and it doesn't have to be internal, right? It can also be external, but usually the goal is to do something within the internal service. And some places to look in the real world, and also here in CTFs, a lot of challenges like to do HTML to PDF, or like some sort of image renderer, a link preview, that's a pretty common one, webhooks, external resource imports, so services that need resources from somewhere else. And if you have access, if you have control over where the resource is fetched from, that could be a potential SSRF vector. So that's some ways of kind of exploiting SSRF. SSRF is very broad. There are many different ways, but usually the goal of SSRF is to access something that you shouldn't be able to, right? So on AWS, there's this URL, and on Google Cloud, there's also this URL where you can access metadata of the internal kind of cluster. And usually, I believe the AWS metadata gives you some secret keys to access like tokens, secret tokens to access things inside the AWS like cluster. So let's say the service has an S3 bucket, so like a storage bucket. You can use keys that you get from here to access it. And that's obviously not good. And there's also it's not really a subset, but it's kind of tangentially related. So local file inclusion allows you to use this file protocol. You might have seen it. So if you open like a local HTML file on your browser, they'll use this protocol. If the server code somehow supports it, like PHP I believe supports it, you can use this to access local files on the machine. So it can be even a bigger problem because you can access source code and stuff like that. And you can use SSRF to do internal port scanning. So let's say you have another vulnerability that you want to use, but you don't know which port is open and what ports are, what services are behind the ports. You can use SSRF to kind of check whether a port is open or not. So it depends on the service that's running.
I'm running like a Google Cloud VM. I can access that URL in the VM.
Yes. So this VM, as you can see, it's .internal. It's not. I don't think it's accessible from the outside world. But if you access this from the machine itself, so the VM that's running the web server, yes, you'll be able to access metadata from the machine. So the reason why you want SSRF is because you're using the server's identity to do things, right? So when the server accesses this, it's okay. But when you access it from the outside world, it actually doesn't work because it's only intended for an internal network. So within here. And this is a very simple example of SSRF. If you guys have used Python, request is a library that allows you to make requests from your Python code. So this is an endpoint that allows users to fetch something. So let's say I want to fetch google.com. So you can pass in HTTPS google.com, and it'll get it for you and return it to you as a plain text. But let's say you have an internal service running at 10.10.0.0.2, and it has a flag. But this is only accessible internally, right? If you pass this in over here, you'll make the server request it for you. You don't actually request it. So those are two different things, and you actually are able to retrieve the flag. And usually, you want to put some filters on a URL. That's how you prevent SSRF. You might want to say, okay, this URL, this IP cannot be internal, or this URL has to start with this paste bin or something like that. Depends on what your purposes are. There's also, blind SSRF, which is probably the most common, where you can do SSRF, but you don't see the results of SSRF. So you might have to use different vectors to figure out, okay, does SSRF work? So there might be response codes that give you hints, response times. So you can have timing attacks where you're like, okay, this port might be open if this web request returns after like only it times out. But if it is not, if it is open, it might take like 2 seconds to load. So you can use that timing. There might be error messages, but usually it's the first two, I believe. Okay, so that was all. Those were 4 attacks. This Sunday, we also have cloud security. I believe some of the stuff that we'll talk about in cloud security might overlap with this. For example, the AWS metadata services. So, if you come, you can learn about it more from who's running the meeting? Sagnik, yeah. Yeah, and here are some challenges on the internal CTF for each of the categories. I hope I didn't miss any. And for me machine, I think it was in false CTF, and it's a bit hard if you don't know what you're looking for. So there's an article attached to the slides if you want to click into it. That gives you some inspiration. And yeah, thank you.